Look at another practice AP question. We've got a particle that moves along the x-axis so that acceleration at any time t greater than 0 is given by 12t minus 18. At time t equals 1, the velocity of the particle, v of 1, is 0. And the position, x of 1, is 9. Write an expression for the velocity of the particle. So we see this type of problem quite a bit, a particle moving along the x-axis. So we're picturing, it's basically like when you read a particle moving along the x-axis, you can say someone driving a car. And you can literally just picture someone driving a car, and they're going this way, and they're going that way, and they're going this way. That's all it means, is you're driving a car in a straight line. Whether that's forwards or backwards needs to be determined by the velocity equation. So let's talk about that when we say particle moving. Write an expression for the velocity. So if I have the function for the acceleration and I want velocity, I just integrate. So the integral 12t squared over 2 minus 18t plus c. That would be my v of t. Now, they have told me that at time t equals 1, my velocity was 0. So how do I interpret that? I need to put a 1 in for t and a 0 in for velocity and set them equal. So it's a little different than just putting the number 0 in for c. So let's take a look. V of t equals 6t squared minus 18t plus c. Now, v of 1 is 0, so when I put a 1 in, I put a 0 in, plus c. So this is how I'm going to solve for c in this one. So 6 minus 18 on this side is a negative 12. I'll add it over, so c equals 12. So my 0 equals 6 minus 18, which is negative 12. So it looks like I'm going to get c equals 12. So my velocity equation is 6t squared minus 18t plus 12. That's all I need. That's my expression for the velocity. So let's clean that up. So let's look at B. At what values of t does the particle change direction? So it would change direction when its velocity would change from positive to negative or negative to positive. So we can find that by just setting the velocity equal to 0 and knowing that if it's not equal to 0, it's going to be positive or negative. So let's do that. If I set this guy equal to 0, I can probably factor out that 6. T squared minus 3t plus 4. Plus 2. There we go. I was confused there. So t minus 2, t minus 1. So our options are 2 and, or I guess 1 and 2. So the justification here would be we need to make sure that it's not just equal to 0, that it changes. So we'd again do our number line. 1, 2, and we'll just try a number. We'll try 0. At 0, I have a negative times a negative, which is a positive. If I put in a 1.5, I'm going to get a negative times a positive, which is negative. And if I put in a big number like 3 or higher, I get a positive times a positive, which is positive. So it does change. So at 1, changes from positive to negative. And at 2, it changes from negative to positive. So it does change direction at both of those. All right, part C says, write an expression for the position of the particle. So we took, in A, we took our acceleration, we integrated it to get the velocity. So I think, again, we're going to integrate the velocity to get the position. So I'm going to have 6t cubed over 3 minus 18t squared over 2 plus 12t. And don't forget our plus c, of course. So I'll clean that up. X of t equals 2t cubed minus 9t squared plus 12t plus c. And again, we are given the information that at 1, the position is 9.
Still trying. Get it from Christmas break.
Just give up.
So let's put that information in. 2 minus 9 plus 12 plus C. So it looks like on this side we've got 14 minus 9, which should be 5. We're going to subtract that over. 4 equals C. So my equation is, for my position is that. There we go. Find the total distance traveled. So total distance traveled would be different than distance from start from 3/2 to 6. So one thing we need to keep in mind there is that we do change direction at 1 and 2. So this change of direction at 2 is going to come into play. So we said at 2 it changes from negative to positive. So here's what I would think this would look like. If we do x of 1.5 minus x of 2, that's going to tell me my change in distance from 1.5 to 2. And if I do the absolute value of that, plus x of 6 minus x of 2, that's going to tell me that change in distance. And if I add those up, I'm going to get my total distance traveled. So plugging these in, and this is a calculator problem, we get this value would be 0.5. So my distance from there to there is 0.5. It's actually negative 0.5, but the absolute value of that. And then from 6 to 2. At 2 I'm at 8, and at 6 I'm at 184. So my distance traveled there is 176. So my total distance traveled from that time is 176.5.